So we're going to talk about solving some basic equations. These are going to be linear equations in one variable. Before we get started, we should identify what a linear equation is in one variable and recognize what isn't. And so this first example, 5 minus 3x, or 5 is equal to 3x plus 2. The variable has an exponent of 1. That's the only variable that's there. And so that is a linear equation because the exponent is 1. My second example that's highlighted in blue, there's only one variable, which is x. It's represented twice in this equation. It's x squared plus 9x plus 9 is 0. And since I have a squared term here, the exponent is 2, and that's actually what we call a quadratic equation that is not linear. And the third example that is not highlighted, I have 2 is equal to 1 divided by x plus 1. And the x is in the denominator there. And even though it doesn't have an exponent attached to it, so we assume that's 1, it's in the denominator, so that's not linear. So the equations that we're going to be looking at are going to look like this first example here for the most part. They might be a little bit simpler or a little more complicated. So before we get started, I want to talk about some properties of equality. And so it's if I have an equal sign between two things, if A is equal to B and C is a number, so C is any number, I can add C to both sides of that of this equation. So if A is equal to B, then A plus C is equal to B plus C. And similarly, A times C is equal to B times C. So I can add the same thing to both sides. I can multiply the same thing from both sides. And we get something else for free here because subtraction is the addition of a negative. A minus C is B minus C. So I can add or subtract the same thing from both sides. And if C is not 0, I can divide both sides by the number C. So A divided by C is B divided by C, or B over C. And this is what we're going to use to solve equations. So let's look at our first example. So number 1, let's look at x plus 3 is negative 2. Okay, and so what we're going to do is we're going to analyze the equation. And I see that I'm adding 3 to the variable x. And what we want to do is we want to get x by itself by undoing what's happening to it. So if I'm adding 3 to x, I should subtract 3, but we're going to do it from both sides. And this is something I do that I like to keep track of my signs. I'm going to add negative 3 to both sides. If I add negative 3 to both sides, that helps me keep track of my signs. I'm keeping everything in one line. That way I know that I'm adding it to both sides and not accidentally adding it to the same side twice. So 3 plus negative 3 cancels out. So I'm going to get x on my left-hand side, negative 2 and negative 3. So we're going to be negative 5. So we have x equals negative 5. Well, I can figure out if this is true or not by plugging it in. In fact, you could take any number and plug it into an equation to see if it's true. And so let's check. So I have x plus 3 equals negative 2. And if I plug in negative 5 plus 3 equals negative 2. And so what I'm going to do is I'm going to combine my negative 5 and my 3. And what does that give me? That gives me negative 2 is equal to negative 2. And that is a true statement. So that checks out. So we can figure out if any equation is true with a given number by plugging that number in. And if we solve the equation, we find a number. and we want to make sure it's true, just plug it in. So let's try something a little bit different. Let's try 2/3 times x is 5. Okay, so now we're multiplying x by 2/3. And there's nothing else happening to it, so I only have to deal with one thing. So what I'm going to do is, well, I could divide x by, or 2/3 x by 2/3, because there's multiplication here, but I like multiplying by the reciprocal whenever I have fractions. So what I'm going to do is I'm going to multiply both sides by the reciprocal, so 3/2. So 3/2 times 2/3 x is 3/2 times 5. And if you need to, you can always do this. You can always put the 5/1 if you need to remind yourself that you're multiplying fractions there. 2/3 and 3/2, the reciprocal gives me 1. So I get x. And then 3 times 5 is 15. And 2 times 1 is 2. So x is 15/2. And this one checks out. I'll let you check it out on your own. It's basically, you plug it in the way you did above, and you pay attention to the arithmetic rules, and you simplify everything, and you find out that that's a true statement. So let's step it up a little bit. Let's look at 3x plus 2 is 7. So 3x plus 2 is 7. I have to get x by itself. So what we want to do here is I'm going to undo the order of operations. So we're going to take care of the subtraction and addition first, because that's the last step of order of operations. I want to get the term with the x by itself, and then I want to get x by itself. So I'm going to add -2 to both sides. So 3x plus 2 plus a -2 is 7 plus a -2. I get 3x is 5, because the 2 and -2 cancel out over here. And now I'm just left with multiplication happening to my x variable. So let's divide both sides by 3. And the 3's are going to cancel out. And 3 divided by 3 is 1. So I get x is 5/3. And again, that checks out. So go ahead and plug that in and check it yourself. And let's do one more that's a little bit more complicated. So let's throw some signed numbers and some fractions in here. So that would be number 4. So let's look at -x plus 1/2 is 2. So we have to deal with fractions sometimes, and we learned rules for adding, subtracting fractions, whatnot. And that's the first thing that I have to do here, is I'm going to have to subtract to 1/2 from both sides. So it's -x plus 1/2 plus -1/2 equals 2 plus -1/2. So on the left-hand side, the fractions cancel out. I'm left with -x is, well, I got to figure out what 2 plus -1/2 is. So that means I need to find my common denominator. And remember, this is 2/1. And if I have 2/1, my common denominator would be 2. So I would get 4/2, because 4/2 is 2 plus -1/2. -x equals 3/2, because 4 minus 1 is 3, and I keep my denominator. X is not by itself yet. So if I have a negative sign in front of something, that's really a -1. So I have to multiply or divide both sides of this equation by -1 to solve it. So let's do that. -x divided by -1 is 3/2 divided by -1. And if I multiply or divide anything by -1, it just changes its sign. So this looks a lot more complicated than it is, but it's not too bad. So I get x is -3/2 for an answer. So yeah, fractions, decimals, all that's fair game. Actually, you know what? 0 is a solution. Let me show you an example where you get 0 as. So if I have, so fifth example, if I have 5x is equal to 0, and I want to solve this equation, the only thing happening to x is multiplication by 5. So I'm going to divide both sides by 5. And 0 divided by 5 is just 0. So I get x equals 0. And so, yeah, that's actually a proper solution as well. In the next video, we're going to solve some more complicated equations. We're going to have x's on both sides. Yeah, you might have some parentheses, so you're going to have to use some distributive law. We're also going to talk about some optional techniques of clearing fractions and clearing decimals. And that's in the next video.